Okay, so here we are at the first section of Chapter 9. We are going to look at the basics of sequences and series for 9.1. This is a two-part lesson. I'm going to go ahead and make a lesson video for the whole thing, but the actual notes we take in class will be over the course of 2 days. So let's just get started with a sequence versus a series. A sequence is just an ordered list of numbers. So like 2, 4, 6, 8, 10, 12, 14, 16, and so on. A series is when you add those together. So a series would be like 2 plus 4 plus 6 plus 8, and so on. So for right now, we're going to start by talking about sequences. So we're going to start with something pretty simple. We're going to write out the first 4 terms of our sequence, and here's our rule that we're going to use to write our sequence. So we've got 3n minus 2. Well, a sub n is 3n minus 2, which means a sub 1 is going to be 3 times 1 minus 2. A sub 2 is going to be 3 times 2 minus 2. Then 3 times 3 minus 2. 3 times 4 minus 2 for our first 4 terms. And then we just evaluate using the order of operations. 3 minus 2 is 1, 6 minus 2 is 4, 9 minus 2 is 7, and 12 minus 2 is 10. And if you notice, this one is linear, pretty much. It's going up by 3 every single time. The second one here is not going to be so linear. And we have 2 to the n minus 1. We're going to do the same thing. We're going to take out n and put in 1. So we'd have 2 to the first minus 1, 2 to the second minus 1, 2 to the third minus 1, 2 to the fourth minus 1. And then we just evaluate. 2 to the first is 2. 2 to the second is 4. Excuse me, 2. Let's fix that first one here. 2 to the first is 2. 2 minus 1 is 1. 2 squared is 4, 4 minus 1 is 3, 2 to the third is 8, 8 minus 1 is 7, 2 to the fourth is 16, 16 minus 1 is 15. So we're just plugging in each n value to find that term in the sequence. Okay, then another interesting thing that comes along with sequences, series, probability, is the idea of a factorial. A factorial is just a function represented by the exclamation point. It means to multiply all the whole numbers in decreasing order down to 1. So if we start at the bottom here, 4 factorial, we start at 4, 4 times 3 times 2 times 1, and we just multiply them together. 3 factorial would be 3 times 2 times 1. 2 factorial would be 2 times 1. 1 factorial is just 1. And then interestingly, 0 factorial. Technically, factorial helps us list ways to arrange things. So for instance, if we wanted to know how many ways there are to arrange the letters in the word cat, there are 3 letters in the word cat, so it would be 3 factorial. So even if we had 0 things to arrange, there is still 1 way to arrange them. So that's why 0 factorial is 1 and not 0. So then just something else to be careful is with parentheses and things like that. So just make sure that you're paying attention when you do the factorial to what you're actually multiplying. So we can also use factorials to simplify and reduce. So if we have 8 factorial divided by 6 factorial, 2 factorial, 8 factorial can be written as 8 times 7 times 6 factorial. Because 6 factorial means basically 6 times 5 times 4 times 3 times 2 times 1. And then we could also in our denominator, 6 factorial, 2 factorial, our 6 factorials will cancel. 8 times 7 is 56. 2 factorial is just 2, so 56 divided by 2 is 28. Okay, same idea over here. We just got a couple more factorials. Excuse me. I've got 6 factorial times 2 factorial, so that's going to be divided by 5 factorial, 3 factorial. So I'm going to have 6 times 5 factorial. Essentially, that's just another way to write 6 factorial. And then my 2 factorial is just going to stay the same. So I'm going to have 2 factorial. Oops, I did not mean to highlight that. I wanted to write that in blue. So then we're going to have 2 factorial divided by, well, 5 factorial. That's going to be a match with the 5 factorial in the top. And then 3 factorial could be written as 3 times 2 factorial, which so we just rewrote 3 factorial like that. So then we look at what we can reduce, and we have a 5 factorial in the top and the bottom. We have a 2 factorial in the top and the bottom, and we're left with 6 over 3, which is just 2. Okay, so then just using factorial to actually find terms in a sequence. It says find the first 4 terms of the sequence starting with n equals 0. Sometimes you start with n equals 1, sometimes you start with n equals 0. You just have to pay attention to what the directions are asking you to do. And that's going to be the exact same thing that we did on the other slide, where we're going to take out n and put 0 or 1 or 2 or 3 in there. So we are going to have 2 to the 0 over 0 factorial. 2 to the first over 1 factorial. Then we would have 2 to the second over 2 factorial. Then we would have 2 to the third over 3 factorial. Which, when we go to evaluate it, always remember anything to the 0 power is 1. We said that 0 factorial is 1, so it would simplify to 1. 2 factorial, or excuse me, 2 to the first is just 2. 1 factorial is 1, so we would have 2. 2 squared would be 4. 2 factorial is just 2 times 1, which is 2. And then 2 to the third is 8. And then 3 factorial is 3 times 2, which is 6, so that would be 4 thirds. Okay, we want to look at another example here. Again, it's the same basic idea. We've got 3 to the n plus 1. So we're just going to take out n, in this case, and put 0. 3 to the 0 plus 1 over 0 factorial. 3 to the first plus 1 over 1 factorial. 3 to the second plus 1 over 2 factorial. And then 3 to the third plus 1 over 3 factorial. And then when we go to evaluate these, again, anything to the 0 power is 1, so we'd have 1 plus 1 over 0 factorial, which is 1. 2 over 1 is just going to be 2. 3 to the first plus 1 is 4. 4 over 1 is 4. 3 squared is 9. 9 plus 1 is 10. Over 2 factorial is going to be 5. And then 3 to the third is 27 plus 1 is 28. And 3 factorial is 3 times 2 times 1, which is 6. So we would simplify that to 14 over 3. Okay, so then we're going to move on. So the second day of notes would be looking at series. So now we're going to move forward a little bit here. We're going to find the sum. So we are going to start looking at series now instead of sequences. So when you see this notation right here, this is sigma notation, which means you are going to add. Sigma means you're going to add terms. Okay. When you see it, we also did this in Algebra 2. I on the bottom is the index, which is just the variable you are using. That variable can be any variable you want. It could be, doesn't have to be I, it could be X, it could be A, it could be I. Those are some of the common ones. So it is also so I is the variable you are using, and then let's see, N is the upper limit. That's like where you're stopping, and then on the bottom is where you start. So we're going to just kind of look at an example of how that works. So if we want to find the sum of the first term to the fifth term, so we want to go from the first term, because it's a 1, to the fifth term, because we end at 5. That means we're going to find basically 3 times 1, that's our first term, plus 3 times 2, that's our second term. So this is our first term, this is our second term, plus 3 times 3, that's our third term, and then plus 3 times 4, plus 3 times 5. 5. And 5 is where we stop, because it says we're going from 1 to 5. So when we go ahead and add or take care of that, 3 times 1 is 3, plus 6, plus 9, plus 12, plus 15. We add them all together and we get 45. Okay, so let's look at the second one here. Kind of separate those. All right, this time we are going from the third term to the sixth term. So our first thing we are going to figure out is 1 plus 3 squared, because we're starting with our third term. We're going to add that to our fourth term, which is going to be 1 plus 4 squared, plus 1 plus 5 squared. And we are stopping at our sixth term, it says. So we have 1 plus 6 squared. Okay, this says that we started at our third, ended on our sixth. So let's erase that so I have some room to put some work in here. Okay, erase that. So then we just do a little bit of evaluating. 3 squared is 9, 9 plus 1 is 10, plus 17, plus 26, plus 37. And we add those together and we get 90. Okay, let's go ahead and look at one where there is a factorial in there. Okay, so we are starting at our second term. We are ending at our fifth term. And as I'm looking at this, I notice that my index is k, and I had a variable of I in there, which means this here should not be k. This should be I, because we want our variable in our rule to match. So we're going to start with our second term. So we're going to have 2 factorial plus 3. There's our second term, plus we're going to add our third term, which is going to be 3 factorial plus 3. Our fourth term is going to be 4 factorial plus 3. And we're stopping at our fifth, so we would go 5 factorial plus 3. Okay, so then we just evaluate, and we end up at 2 factorial plus 3 is 5, plus 9, plus 27, plus 123, and we should end up at 164. Okay, the last thing that we are going to look at in this section is infinite series and partial sums. Okay, so in order to find the sum of an infinite series, for right now, until we find another way to do it, okay, is we notice that the top, it doesn't have an ending point. It has an infinity that it's supposed to end at. Well, you can't add things up that go to infinity, so we have to kind of find a way to figure it out on our own. So we're going to be finding the sum of the first 3 or 4 elements and looking for a pattern and then seeing what we can do from there. One of the things that's very common with these that we're going to do in class is if you have a repeating decimal, okay, a lot of times when you add these sums that we're going to do in these two examples, you have repeating decimals, and all a repeating decimal is if you have like 0.444444 repeating. Easy way to write that as a fraction. The rule you can follow is 4, and it's always over 9. So like 2 repeating as a repeating decimal would be 2/9. Well, we know 3 repeating is a third, right? However, does that match our rule? Well, 3 over 9 is 3/9, which is 1/3. So anytime you have a repeating decimal where only one number repeats, it's going to be that number that's repeating over 9. So we're going to use that rule here in just a second. So let's go ahead and find the sum of the first, like 3 or 4 of this summation here. So we're going to start at our first. So we're going to have 3 over 10 to the first. I'm going to write a little bit smaller. 3 over 10 to the first. We're going to add that because sigma means summation, plus 3 over 10 to the second, plus 3 over 10 to the third, plus 3 over 10 to the fourth. And 3 over 10 to the first is 3/10. 3 over 10 squared is 3 over 100, which would be 0.03. 3 over 10 to the third would be 3 over 1,000, which would be tenths, hundredths, thousandths. And then 3 over 10 to the fourth would be 0.0003, because that would be 10 thousandths. So if you look, you got 0.3, 0.03. If you add those all up, you're going to get 0.3333. So our pattern that we notice is that it's going to be repeating 3, which is going to be a third. So if we added all of them up to infinity, they would get closer and closer and closer and approach 1/3. Okay, so I am actually going to erase this so I have some room to do the next one. I will put 1/3 up here. Okay, now I have 1 over 10 to the x. So now I'm going to have 1 over 10 to the first plus 1 over 10 squared plus 1 over 10 to the third plus 1 over 10 to the fourth. Just remembering that when we have an exponent, it goes to both the top and the bottom. So 1 over 10 to the first, that's going to be 1/10, plus 1 over 10 to the second would be 1 over 10 squared, which is 1 over 100, which is going to be 0.01. And then we're going to have the same pattern as we did up there with the threes, except this time it's going to be tenths instead of thirds. So we are going to have 0.0001, which is going to simplify. If you look, you got 0.1111, which is going to be 0.1 repeating, which is going to be our rule we learned is 1 over 9. Okay, so then a partial sum is basically when you only add part of the summation. So if we want a third partial sum or a fourth partial sum, so like the fourth partial sum would be finding the sum of the first 4 terms. The third partial sum would be finding the sum of the first 3, and so on. So I basically, if you notice, this is the same equation as I have down here, and then just for the sake of simplicity, this one is the same as this one. So all we are doing, if it says to find a third partial sum, we are just adding our first 3 terms together, which we already have up top. So we said our first term was 0.3, our second term was 0.33, and our third term was 0.333. But since we're only finding those 3 terms, we can add them together, and it'd be 0.333 exactly. We are not rounding that to not changing it to a fraction, because we only want exactly the first 3. And so the same thing, like if we look up here, let's see, these are the first 4 that we would add together for this one. So if we have the first 4, we would have 0.1111, and this is going to be an exact answer. It is not going to be a fraction, because we are only doing the first 4 terms. So remember, to get that, all we did was we said 0.1 plus 0.01 plus 0.001 plus 0.0001. All right, so good luck with your homework. There's the whole video.